My name's Isaac Konikoff. I'm with Candela Technologies. We make network test software for wired and wireless networks. And I'm going to talk to you a little bit about band steering fails, or how do you test something that most people don't use and some people may consider to be obsolete, especially when you consider existing and newer technologies that are coming that are going to use multi-bands. All right, so first, I just want to take a moment and say thank you, Keith, for a great, fantastic conference. I wouldn't be up here today without the encouragement of a lot of people in this room. This is my first time presenting, and so thank you. I love meeting people, sharing stories and experiences, learning from each other. That's what it's all about, and making friends. And recently, one of my WLPC friends gave me some great advice. He said, "Friends, don't let friends turn on band steering." Thanks, Wes. It's good advice. And then he showed me how to turn on band steering. So, does band steering work? Well, the reason I had to turn on band steering is we had a customer who wanted to test if band steering was working in their network. And so I needed to turn it on and lab it up and see how it was going. And what we found is that our LForge client would not be steered. It would stick on a band, and the AP couldn't steer it. So we did some additional testing and investigation, including some testing with some real mobile devices. And what we found was interesting. We found that a Samsung mobile device would be steered, but right before it was steered, it would send a BSS transition management query, an 11V solicitation for a better network connection. And when the conditions were right, it would respond and be steered to the other band. So we set out to emulate this behavior in LForge. And LForge uses the Host AP project, which is an open source project. When we want to emulate an access point, we run Host APD. And when we want to be a client, we use WPA supplicant, which is also under the Host AP project. And as you may know, this is the same supplicant that is used in most Linux devices, including WLAN-PI. And in supplicant is a utility called WPA CLI. And when your supplicant is connected to a network, you can log into the WPA CLI and you can issue commands such as a scan, you can do a roam, or you can issue a BSS transition management query. Well, that's great, but that's a manual process, and we needed something more automated that would behave like the mobile device. So we looked at another supplicant feature called BG scan, background scan. And the way background scan works is you define 3 parameters. There's a short scan interval, here it's set to 30 seconds. There's a RSSI threshold, here it's -65. And then there's a long scan interval, which is here 300 seconds. And the way it works is when supplicant is connected and it detects that its RSSI is at the BG scan -65, then it'll start scanning at the short scan interval every 30 seconds. Otherwise, it'll scan at 300 seconds, the long scan interval. So BG scan was intended to aid in roaming decisions, but it wasn't quite enough for us to behave like the mobile device and get the band steering behavior we were looking for. Also, you'll notice here that I put in here that this is my WLAN-PI that I was using, because you can use BG scan in your WLAN-PI if you want, and you can try this out. So what we did at Candela is we developed a new feature for BG scan called the BTM query parameter. And the way it works is you define this number at the end, which is the number of BSS transition management queries that you want to send. So the way it works is when supplicant is connected and it gets to the RSSI threshold, before it does any scanning, it'll send up to the number of specified BTM queries. And then we got the behavior we were looking for, our client would be roamed. And again, you can use this in your WLAN-PI if you want to try it out. It's in the latest supplicant, which I think is in the latest version of WLAN-PI. The BG scan directive can go outside the network block, or it can go inside the network block if you want to have different BG scans for different networks that you're connected to. So let me tell you about the test setup. We have our LForge device with a station. Here was a AX210 radio, and that it goes to a splitter combiner network with some bandpass filters, so we can split out the 2 gigahertz and the 5 gigahertz. And then that goes to a programmable attenuator, and then that goes to antennas inside of an RF chamber. And then there's a wireless access point that's over the air inside the RF chamber. And the test goes like this. The LForge client connects to the 2 gigahertz, and then we increase the attenuation on the 2 gigahertz until it gets to the BG scan threshold. Then the station initiates the 11V solicitation. It goes through the query request response with the AP, and then it's steered over to 5 gigahertz. Then we remove the 2 gigahertz attenuation and increase the attenuation on the 5 gigahertz path until it gets to the specified level, and then it goes through the 11V solicitation again. And then we remove the 5 gigahertz attenuation, and we can do that several times and see the LForge client being steered from 2 to 5, 5 to 2. I did mess around with playing with 6 gigahertz, but I got some weird behavior, and so I'm not going to talk about that today. I'll talk about that another time. And so this is what we see in the PCAP, where you can see the LForge station going from 2 to 5, 5 to 2, so on and so forth. Now, the question is this band steering? Some people say yes, some people say no. Some people say yes, it's band steering. You went from one band to another band steering. Some people say no, it's not band steering. You used 11V to roam from one radio to the other radio on the same AP. That's roaming, that's not band steering. But we behaved like this real device. It is band steering. But you did this in a controlled lab environment. Why don't you go in the real world and see what happens to you? And that's a great point. But I'm going to leave it for you to decide. Is it band steering? If yes, why do you think so? If not, why not? Thank you very much.